So I want to thank Michael and Cecil for allowing me to talk today. Calvin is one of my oldest friends, and I guess by oldest, I mean he's one of the oldest guys I know. Much better. I need a laugh track. It's really tough when everybody's muted. Anyhow, Calvin is one of my oldest friends, and he has helped me tremendously through the way. So I have a lot of stories about him, some of which I can tell, and they'll be sprinkled throughout the presentation. So I guess when it was a good thing and a bad thing, Cecil said, would you like to talk at this Calvin presentation? I said, that would be great. And he said, I want you to talk about specifications. And I just had this idea of everybody falling asleep real quick as we go through specs, which is a sexy topic. But anyhow, it is an important topic. When you take a look at this old cartoon, suddenly a heated exchange took place between the king and the moat contractor. They're building the moat inside. I've written a couple of these specifications that ended up with the moat inside the castle. I've seen a couple other ones. And I want to go through kind of some case studies of history of the things that I've seen and kind of how that shaped my mind about how specifications should be written. And hopefully it's interesting. So I started my career off here at Maryland State Highway Administration, I guess professional career after I became an engineer. I did a lot of work in construction before that, and a lot of my family are contractors. So kind of grew up in the business, but my real professional career started here, and it's a really good place to start for any young engineer. You get a lot of experience from a variety of different types of applications, soil, asphalt, concrete, and I ended up kind of by mistake into the concrete world. I guess that would be many of us could sit here saying, you know, when you're 5 years old, you didn't say 1 year I'm going to be a concrete engineer, and that's what I'm going to guide my life toward. You kind of fall into it and find out it's a good thing. How long ago was that? Well, it's that long ago. Every one of these gray hairs in my head is a specification that I've written that somebody isn't following today. Now, I'm not this old. I wasn't around when they did the great roads back in the 50s and the Eisenhower highway system was built. But the guys that taught me largely were around at this time, early on, the old state guys when I came on board. And they had grown up in the Wild West. When they were building these roads and the beginnings of it, there weren't a whole lot of specifications. And the ones that were written, there wasn't a lot of enforcement of it. And a lot of things were being done that were being done improperly. And these guys were tough, but they were tough because they lived through some interesting times. And they had to write the specifications, and they had to make sure that they were enforced properly in order to build the roads that we enjoy today. And I have a tremendous amount of respect for them. But early on, these guys really shaped how I thought of for how a specification should be written and how it should be enforced. And it was very, black and white. It was, these are the specifications. This is the old Maryland State Highway spec. It's actually a little bit updated. I think we only had about 8 mixes when I worked there. The specification was 90210. And for years, I told everybody, and still do, that I wrote for 90210. And so a young engineer came in. I'm in the materials section. I'm going to work there until something better comes along because I really want to be a design engineer. And they teach me these specifications and they get you to memorize them. And I worked in materials, so they're very much into what the material should be. And then they send me for a year out in construction to see how these specifications are used out in the real world. So my first month out in construction, you really, unfortunately, and this is true to today, most engineering programs do not teach you a whole lot about concrete and the test for concrete and what they mean and their importance. So one of the engineers at the field office, State Highway, took me out on this job. It was out on I-97, if you're familiar with Maryland, right up around Annapolis. And he took a slump cone out, and with no concrete at all, standing out in the parking lot, he said, "This is how you run a slump." And, he just showed me very quickly how to do it. He gave me a slump cone and a rod and a tape measure. And he sent me out to inspect the footing. He said, the concrete trucks are going to come. When they come, you run a slump. You know what they need to be within. And, if they're out of spec, you send them home. So first truck pulled up and I measured the slump, and it was a 1/2 inch over the specified maximum. And I told the truck driver, okay, get it out of here. It's out of spec. Now, I think that they're not sending me out to anything important because I'm a new guy and I really don't know what I'm doing. It was probably, a foundation for a signpost or something like that. And, I'm all by myself with one other guy doing this. And all of a sudden, I have about 30 guys surrounding me telling me to run the slump again. And I think I ran the slump about 10 times. And they're telling me different things. You need to twist it when you pull it up, and you're pulling it up too fast or you're pulling it up too slow. Well, finally, everybody here realizes when you sit there with the concrete in the wheelbarrow long enough, the slump tightens up, and it finally got to where it needed to be. And they were allowed to use the concrete, which is as it should have been for what it was used for. But it is when I learned this term, engineering judgment, because I went back and I was kind of shaken up and I said, I think I really blew that. And everybody's laughing at me. And they said, were you really going to send a truckload of concrete back because it was off a 1/2 inch for a foundation for a sign? So I guess at a very early time, I started to take a look at these specifications and saying, there's some wiggle room in them. And, could this have been written more clearly for the application that I was looking at? And just starts you to wonder. Came back and I started to work in research, and we had a very interesting project that really is the thing that pushed me onto my career as a concrete engineer. This project was, we were experiencing a lot of bridge deck cracking, and it was early on, and they were mostly transverse. You would have, on the worst decks, it was one every foot. It was usually you had a longitudinal crack that went down. So my job was to go out and measure all these cracks in the bridges, map them out, and try to determine what was causing these cracks. So I wrote a report on it. My recommendation coming out of the report was that, and this recommendation was based on me talking to every one of the older engineers that I knew and explaining what was going on. And so when I say it was my recommendations, it was really a lot of smart guys that were helping me out with this. But we collectively felt that there was a curing problem going on. And so I talked to some of the other state highways to find out what they were doing. And I came back with, there's a method of curing, and it's called fogging. And we really should be getting into that and see if that'll straighten things out. So they said, that's great, go write a specification on it. So I did. And this is what was in my mind when I wrote this specification. And I think I had something about they were atomized water molecules flying out of the thing and creating a mist over the concrete, a fog, and raising the humidity above the concrete. I had all this stuff in it, and I just thought it was great. And my first spec didn't really go so well, because when I went out to see if people were actually doing this, I found out that mostly people were using garden hoses and calling that an atomized spray. And you're going out. I went out on every bridge deck over a 4-year period that was placed in Maryland. And you walk out on the job and you tell people, no, this isn't what I intended. And they go, well, that's interesting. A Calvin term. That's interesting. What do you mean by atomized? Can you tell me what that is? And they started to pick that specification apart. And I realized that what I had written was really not very good. And it was confusing to everybody. And it was open to an interpretation from the contractor that could take us down some bad roads where they were really adding a lot of water to the surface of the concrete and doing bad things to it. So I hope Cecil's still on. I wish I had a better picture of him. That one came out a little blurry. But if you know these two guys, there's Cecil on the right and there's Chalik on the left. Chalik Lidrium from down at the Virginia Research Council. And this is something I found out real early in my career. I went around trying to find people that could help me out with this. And I found out that these two guys knew a whole lot about curing. And I called them up. And if you know, well, we know Cecil and you know Chalik, they're two of the nicest guys in the world, two of the kindest guys in the world. They did not make me feel like I was an idiot for the questions that I had or for the bad specification that I'd written. And they kind of walked me through maybe how we wanted to proceed with Virginia and with North Carolina. And I think Cecil had the idea of putting wet burlap down. And he said, why don't we tell them, nobody likes to do this fogging. Why don't we just tell them, you know, you can fog or you can put wet burlap down within a half hour. So writing a specification saying you need to put wet burlap down within a half hour is a lot easier than writing one talking about atomized, you know, water particles flying out of a hose. So I wrote it, and I thought it was great. And I went out for a year to take a look at the bridges to see how this was going to work. And nobody wanted to do this, and nobody did do this. There was not buy-in from the contractors, and there was not buy-in from our inspection division. And it's when I found out that when you make a radical change to a specification, you can't just write a spec and think everybody's going to do it. It is that engineering judgment that you find out in the field. A lot of times people are going to look at that and say, I don't think that's a good idea, and I'm just not going to do it. And it doesn't happen. So I reported back, did not rat out any specific people that had done bad things, which a lot of them had. And it got to be kind of interesting at this point. And I think this is when I became in contention for the spot that was opening up as concrete engineer, because it wasn't because I was real smart. It was probably because I was real dumb and just kept going at something over and over again and wouldn't give up on it. But the other thing is that there were a lot of people that were out on these bridge decks that were actually threatening physical violence. And a lot of the guys said the only reason you're getting this job is because you're big and you're too big to throw off the side of a bridge. And that's the truth. I was out there a lot of nights where people threatened to throw me off the side of a bridge for putting wet burlap down on a bridge deck, saying this is going to ruin the bridge deck, and you're a young engineer and you don't know what you're doing and all of this. But I had the backing of a guy named Jock Friedman in Bridge, and he was a god in State Highway Administration. And when he gave me the backing, people had to do what I told them to do. So we had about 30% of our bridges that cracked ahead of time early on, and I would say within the first week after you placed it. And after we went to wet burlap, which was really Cecil's idea, we stopped the cracking. We went down to zero. And it was very impressive, but it was one of the things that I found out early on. You can't just write something down and think people are going to do this now. You really need to go out and enforce it and make it happen. Another thing I found out, we had a guy that came in and he was a very good salesman, and he sold us on super plasticizers, high range water reducers. And they were the old style, old generation high ranges. We had melamines and naphthalines, and some of them work good and some of them, actually work not so good. And his product didn't work very good. But he sold us on this, and we did a little bit of work and it looked good in the lab. And when we got it out in the field, it was a disaster. We had horrible slump loss, and it would come flowing out of the truck into a wheelbarrow, and it would start to lose slump immediately. And it was a nightmare. And I sat out on a couple of those projects, and we wrote high range water reducers out of our specifications. Now it's 30 years since then, and high ranges are still largely prohibited for use in Maryland. And I guess that was another thing that I learned that helped me on the side of the fence that I am today. You need to really know your product, and you need to have faith in it, and you need to be very truthful about what it can do and it can't do. Because if you recommend something, if you tell people to do something and it doesn't work out, you'll lose your credibility, and you'll probably lose your chance of ever getting back in and doing that again. When I was with the state, we discovered ASR, which had actually been discovered 45 years before us. I remember I was going to night school at the time, and my professor asked me, does anybody know what ASR was? And nobody did. And he offered extra credit if we could find out if we had a problem in Maryland. And I went back and talked to all the guys in the lab, and I was still one of the real young guys. And they told me, yeah, they knew what ASR was, and they explained what it was to me. And then they said, but Maryland doesn't have ASR. We don't have reactive aggregates. And it wasn't a problem. And I went back and talked to my professor, and he said, well, you told me what it was, but I'm not giving you any points because I'm being sued right now. He was working on the Washington Metro project, and they were finding ASR all over the place. And they're saying he should have known about it. So I wasn't the genesis for this, but shortly after this, we did find out we had ASR, and we found it in the highest inland bridge in Maryland, Route 68 and Maryland Route 55. And this thing towers above the road below. The worst place in the world you could find this problem on. They had noticed all the cracking in the deck. They had ripped the deck up. They had redecked it. And, shortly after doing this, I would guess in a 10-year period, they started to see this cracking problem again that was ASR. So everybody is spinning around and, what do we do? What do we do? And I remember, not me, but somebody wrote a specification, and it said, there will be no, we will not use any Portland cement where the alkalis are above 0.60. And the very next day, we had about 4 lawyers with 4 producers of cement in the chief's office ready to sue us for that. So everybody said, okay, we're going to step back from that. And because when you work for the state, you really don't want to get sued. It ends up in the newspapers. You don't want to get sued unless it's something that you're dead sure of. And we weren't dead sure of this. So we went back, and there was a Maryland, it was actually a Mid-Atlantic Technical Committee. And this is the technical committee. If you take a look in there somewhere, you'll find Calvin McCall. I think he's behind Einstein somewhere and in front of Schrodinger. Anyhow, very smart people that were there. I didn't know Calvin at the time, but I was reading all the notes from the meeting. We had a real smart guy from our side, John Wiesner, that was in that. And these guys wrote a really good guide for how to deal with ASR. And it was a good time for the industry, because for a short period of time in the Mid-Atlantic, everybody was kind of in agreement about how to address ASR. And there were some small differences, but everybody was pretty much on the same page. And it's important for concrete suppliers and producers and contractors to have consistency in major specifications across the region. And the reason for that, and we have kind of a mess today because it's a lot different, but if every state has its own specification, if you live in a small state like Delaware or like Maryland, and you're a concrete producer, you might do work in 4 different states very easily. And if you're a contractor, you definitely will be doing work across state lines. If you have these big differences in a specification, it becomes a complete nightmare. And so it's one of the things that I have found, and I try to work on, that when you write specifications, they are good for several different groups. I don't have any pictures of Calvin. And that is amazing. When I went through my book, I guess we had some pictures at one time, and we agreed that they were of an incriminating fashion, and we needed to get rid of them. Nobody needed to see us with pictures with glassy eyes and cocktails in our hands late at night. So I actually do have those pictures, but I'm not sharing them. I throw this one of Calvin and me, early days. Calvin has a tear in his eye, as I do. Blue Circle Cement. I left the state. I went to work for these guys. I kind of knew what I was doing as far as how to build a bridge and how to build a highway. I didn't know a whole lot more than that. I had a lot to learn. And early on, I don't know if Calvin remembers this or not. We shared a rental car together. We were up in Albany, New York, and we were driving down to Ravenna. And I got in the car with Calvin, and we started to drive, and Calvin started to talk. And I realized that Calvin was one of these smart guys that you really, really wanted to know and you'd like to become friends with. And I don't know if Calvin remembers this either, but he told me, you seem like a nice guy. He said, I'm not sure if we're going to be friends or not, but I will do anything I can to help you. And I am very glad to say we are friends, and we always have been. And we became friends, I guess would be the better way of saying it in technical language, and good friends. And Calvin has helped me throughout my career. So I'll give a little side here on Calvin. Calvin's smarter than me, and that's most people are. Calvin's a lot smarter. And it was kind of interesting early on because I didn't want anybody to know how dumb I was and how much I needed to learn. And so, Calvin would start talking over my head, and I would change the subject when it got real far. And I thought, I don't want him to figure out how stupid I am right now. And then one day I was talking to Tom Green, and I asked Tom, I said, do you ever have these conversations with Calvin and you just start to lose it? You don't know where he is anymore, and it's just way over your head? And he said, yeah. I said, well, I always just change the subject. What do you do? And he said, well, you're an idiot. He said, if you want to learn something, Calvin's the guy to go to. And I said, when he starts talking over your head, you can tell Calvin, stop, I don't understand what you're saying anymore. You need to explain this to me in terms of beer. Now, that to me is what makes Calvin the most remarkable person that I know, because he does have this genius side to him. But the more genius side is that he can explain nuclear physics to you in terms of Heineken's and Sam Adams, and you'll understand it at the end. So I guess that's my recommendation to anybody. If you're talking to Calvin and he goes over your head, just stop him and say, let's get into the beer discussion right now. I need to figure this out. Since I left the state, things that I have done with specifications and things that I have learned and have guided me on my path. One of them is the Chesapeake Bay Bridge. It has an actual name to it that nobody in Maryland uses. We call it the Bay Bridge. Bay Bridge is important. It's one of the 10 scariest bridges in the United States to drive over. I get a thrill out of heights. It doesn't bother me at all. I like to be up high. So I like the little bit of involvement I've had on this bridge. And I did some when I worked for the state. And afterward, I was called in by State Highway, who was consulting with the Transportation Authority. This bridge links the Eastern Shore to the rest of Maryland. It's the main route you go to when you're going down to Ocean City, Maryland. Ocean City, Maryland is a smaller bridge or smaller city. And but in the summertime, it's the second biggest city in Maryland. So everybody in Maryland is driving over this bridge to go to Ocean City. There are two bridges. They were built separately. One of them, I believe, was built way back in the 50s, and the other one was built in the 70s. The one in the 50s, the deck was going on it. They didn't want to do a complete redecking, so they were coming in and they were patching, and they were doing wide swaths of patching. And it ended up that a lot of these patches were delaminating. And there was about $7 million worth of work that had to be ripped out and redone. And it's an interesting thing. And if you take a look in Engineering News Record, it's a very interesting story that you could do a whole presentation on. In the end, I guess, having worked for the state and dealing with problems, $7 million sounds like a lot, but $7 million on any other project probably would have been buried and nobody would have known about it. Because it was this bridge, it was in the news all the time, and it was a real big deal. What I liked about this was that they did not go after people to try to burn them. From what I could see, the commission that was set up was to figure out what went wrong and how to make this go better. Some of the things that I saw, the contractor had warned that the bonding agent that they were going to use had caused debonding issues in the past. And that definitely could have been one of the issues. They also went into the temperatures that they used it in, and there were a lot of different problems with how this was applied. The problem for me, and the reason why I was brought into it, is that we actually had a spec in State Highway that was a very good one, and we had used it after we had had similar issues. And it was something that the Transportation Authority could have just grabbed right off the shelf and used, and it would have worked very well. And it was based on a lot of things that other states had done, mostly New York, who had a lot of experience with it. But it was one of those things that I saw. The engineers on this project, who were very good, were trying to do something that was going to be better than what we had done in the past. And they had silica fume concrete and a whole lot of other special things. What they were trying to do was build a Cadillac, and what they ended up doing was causing a problem. And they went back and they made the adjustments they needed to, and it got fixed. I dealt with the guys on the next project, and that's why I know that they were very sharp engineers for the state. And they ended up, we had this project on I-95, I-695, and a lot of mass concrete. The concrete was placed in the summertime and the wintertime. It gets real hot in Maryland in the summertime, and it gets cold enough in the wintertime. They wrote, and I've dealt with slag cement and mass concrete for about 30 years now. They wrote one of the best specifications I've ever seen for using mass concrete with slag cement. Problem with slag cement is you get all the strength that you want, but when you get cold temperatures, you don't get the strength early on in place in the structure. So stripping forms becomes an issue, and you can slow the project down. They number one, they figured out where the temperature differential was, which was a lot broader than what I would have given them, but through a lot of good engineering work and design work, it worked very well. And they allowed a higher differential in the wintertime. And they did this by tying everything to the ambient temperatures. If it got below a certain temperature, they knew the concrete temperature was going to be cool enough. And it was one of the best projects I ever worked on as far as mass concrete. Very easy for the contractor, very easy to understand. No arguments on this project. It worked great. Worked on another project, and this was Woodrow Wilson Bridge. And this bridge, another one with a lot of mass concrete. And initially they said 50% slag cement in it. We talked to Virginia DOT and Maryland DOT, and they're very good partners to have. And they very easily changed this specification around. One of the projects I really got to meet and work with John Guida on, who is one of the experts in our country on mass concrete. And it led later on to working on the ACI 301 committee. John said, I think we should have a thermal control plan that's required in these mass concrete jobs. And I completely agreed with him. And that project was one of the things that kept it in my head, because they were about to go down a road that would have been bad for them. It's a good thing to stop beforehand to say, we have something different, we have something special on this project, and we need to address it. And that's all that this thermal control plan does. Let's take a look at what we've got and let's address it. I've run into a lot of things like this today, and they're hard. They are mixes where they have coarseness factors and workability factors, and there's a lot of fibers and a lot of mixes that are going out. When you run these mixes in your laboratory, a lot of them will look ugly. And when you talk to a contractor that has used it somewhere else, they said, well, I did fine when I was out in Ohio. And I don't think that what people realize is that the materials in Ohio are different than the materials that we have here. I can't match these perfect gradations that people are sending me. You do the best that you can, and you really struggle with this. So let me see if my video works. You have something that's ugly like that, and this is what the contractor wants. And somehow you need to work between the engineer and the contractor and the concrete producer to make something like this work. And to do that, you need to have that engineering judgment. The engineer on the other side that designed this needs to work with you. Have projects that go on with this too. And I actually like to do this. You know, anytime you can flip a slump cone upside down and you don't have to rot it, it's a good time for me. But you want concrete that will flow throughout a form. A lot of times you're looking at something with a very low wood or cement ratio. A lot of times these mixes get a little bit strange. And here's one of the mixes that I had for one of these projects. These are, 100-year service lights. You see my buddy laughing at it. And this is the mix that they wanted out there. And this is the mix that they're going to pump out on the job site. Try to see if I can wait until it becomes concrete. I don't think we can wait that long, but you can kind of see the waves starting to appear. So you're batching this concrete out in the laboratory, and you're just wondering, can this concrete, how are they going to place this concrete in the field? That's as hard as I can push down into the concrete. It's a little bit tough. And then you make cylinders with this stuff, and it gets to be ugly looking. And you're wondering, how is this stuff going to flow in the field? How is it going to consolidate in the field? There's a lot of projects that are set up for over 100 years. And theoretically, a lot of people have come up with ideas how to do it. I think there needs to be a conversation between the people that academically are putting a lot of these mixes together and the guys in the laboratory that are doing this. And I remember the last ACI convention we went to, there was a lot of discussion in one of the sessions. It was a very good session, and it was about how to make these mixes. And you had a lot of people theoretically get up and talk about how to do it. And then there was a contractor at the very end, and he said, all of that kind of works. And in the end, you need to sit down with the guy in the laboratory that is mixing this concrete together, and you need to figure out how to make it work out in the field. So I think it's one of the things that we probably as an industry need to do a better job of having that conversation and sharing the knowledge from the academic side of how these mixes should go together, and from the realistic contractor side of how am I going to pump this concrete, and I don't want to have any voids in this concrete when we're all done. All right, so how do I address specifications? And first of all, I'm going to jump in real quick. I'm almost at the end in case the timekeeper's worrying. I think I'm ahead of time though. I was kind of working happily along in my life, and I would come to ACI and I would attend sessions, but I really didn't work real hard, and I probably more the social aspect more than I should in a lot of cases. And then I got a new boss, and he wanted me to be on committees, and I said, Calvin, can you help me out? Because as Cecil said, Calvin is the guy at ACI. And Calvin said, well, I can get you on 301, but you're going to have to work. And that worried me, because when Calvin says you're going to have to work, you know you're really, really going to have to work. So I said, well, okay. I said, that, I would appreciate that. And Calvin got me on that, as well as some other committees. And he put me to work. And my hope was, you get onto 301, it's a very intimidating committee for an outsider. And once you're on it, you realize that everybody on this committee is a very nice and very decent people. They beat you up, but they laugh while they're doing it, and everybody's friends on the outside. But they're very smart people. And you're walking in here with your limited knowledge that you know, and you're very, you have trepidations about getting up and talking in front of this group. So I said, Calvin, I just kind of want to sit in the back for a while and figure out how this all works, and kind of keep quiet and not have to, until I get my feet wet, I don't want to be, in the middle of anything. And he said, oh, don't worry about that. And I think the next convention, he had me get up and talk at the convention in the 301 committee, and address some negatives. And he told me the day ahead of time, hey, you're getting up, you're going to do this. And I remember having a couple people holding my hands and bringing me bottled water as my voice shook in front of the crowd. But he threw me in the deep water, but he didn't just throw me in, he helped me swim. So I don't want him to get too much of a swelled head, because we're going to bring him down later on today. I kind of wind this stuff up with some of the things that I've learned on this spec writing from Calvin largely, but from all the other good people that I've met in my life that have helped me along. So my number one thing that I learned is we have structures that we're building, and it has to be safe. You can't do anything that's going to impinge the safety of the building. You need to protect the owner's interest. You don't want to put something up there that's going to fall apart in a number of years, and the owner's going to end up with a huge headache. How I've changed from when I work for the state is I need to consider, or we need to consider, how the spec will affect contractors and others down the line. So you want to do all those things in number one and number two, but you don't want to beat up some poor contractor or some ready-mix producer needlessly doing something they really don't need to do. We work as a team on this. You need to write clear and meaningful specifications, and you need to keep them as simple as possible. And you need to stay current, because every couple years, I guess it's every 4 years or so, we're rewriting this document. And every time we rewrite it, I think, wow, we've done this, several times over. It should be good by now. But the world is changing around us. We have, carbon issues that are coming at us right now, and the world of cement may be different 10 years from now. So all of that changes, and our specifications need to change with them. And I really feel that avoiding nuisance type specifications is very important. There is one of the things that, since I've been on there, a lot of good work has been done at pulling the type of specifications out that really don't mean much, but really cause a lot of headaches, and lean on the expertise of the subcommittee and the main committee members. So I always try to surround myself with the smartest people that I can, so that they will carry me along to what I need to do. Example of this, and this is a simple one, and it goes back to the first test that I ran out in the field, and that's slump. And we used to have a range, and this is what you needed to do. Right now, the way that we rewrote this is, the contractor and the ready-mix producer needs to talk about what kind of slump that contractor needs, and they get together on that, and they work that target slump out. And I think that is a really brilliant way to use a test method that this is what it was intended to do. We wrote a specification on ASR that was a tough one to write. And we took the guide from ASTM, which is a little bit difficult to go through. And there are different avenues that you could go down in this guide. And some of them are ultra conservative that would have really locked a lot of our construction up. And some of them are very commonsensical, and they're conservative, but they're can be done by, you have to take a look at writing the specification again over vast regions across the United States. Can we do this? So we wrote a specification that's very straightforward, and we're looking at, you have different options. You can use non-reactive aggregate. You can test by ASTM C1567, or you can limit the alkali loading of the concrete. Pretty straightforward. And we give them an out that they can go back to C1778 and they can come up with something different if the engineer chooses to do so. I really like it because we took something that was kind of complex and we really simplified it down, but we kept the guts of it. We kept the safety factors that we need to, and we're looking out for the owner. And it's important because when you take a look today at where ASR is, it's all over the board. There's a million specifications on ASR. It can be very confusing if you're out in the field working with multiple states. End up with this, I talk about specifications and enforcement. One of the things that I see today is we're going down the wrong road as far as enforcement. I'm seeing some strange things out in the field. Michelle talked about Calvin wearing sandals at a meeting. When you're wearing sandals doing a slump test, we're in the wrong direction. And I see that a lot. And I guess as I get old, it frustrates me when you're looking at, this is supposed to be a 6-inch maximum slump. They were having strength problems on the project, and they were allowed to go much higher than that. And of course, this is where the strength problems happen. You're adding water to the concrete. So I see a problem with enforcement today, and I think we need to do a better job with that. And I should have ended on a positive note. That was kind of a downer. I'm sorry. So that is my presentation.